Okay, well, we looked at about converting back and forth between fractions, decimals, and percents, and also benchmark percents, so we can solve percent problems. We talked about a couple of them. How do you calculate tax? How do you calculate tip? How do you, for those of us who don't have a lot of money to blow, how do you calculate whether or not you can afford something with a discount plus tax, all this kind of stuff. So just being, if nothing else, all this will help you become a smart consumer. All right. So if you want to, students examine 140 vehicles in a school parking lot and find that 15% of the cars in the sample have oil leaks. How many cars have oil leaks? All right, now I know you can probably go straight to the answer, but I want us to use our benchmark percents to show how you can check the reasonableness of your answer. Okay, so 15%. So if I'm talking about 15% of 140. Okay, well let's see. I can break that into 10% of 140 and 5% of 140. So we know 10% of 140 is going to be 140 divided by 10, which gives us 14. Well, 5% is half of 10%, so 5% of 140 is going to take this and take half of that, which gives me 7. And then when I add these two up, I get 21. So using this method, I get that 21 cars out of a sample of 140 have oil leaks. Now again, many of you have already figured that out, but this is a demonstration on how the benchmarks can help you to check the reasonableness of your answer, again, in case you make a calculator error or just, you know, you're not sure you understood the problem or something of that nature. All right. This is the big guns for this one. This equation is unbelievably important. This is the equation that you are going to use to solve all of your percent problems. Now I'm going to tell you, I bet many of you in your high school career or in your middle school career or wherever you learned your math are going to want to use proportions. I'm going to steer you away from that because having this equation will help you solve more types of problems. We're going to get into things that may be a little bit more difficult for you. Okay. All right. The percent of the whole is the part. Now there are a couple of things that you need to know about this. Anytime you're dealing with an equation, the percent has to be changed to a decimal. Of means multiply. So you're looking for a percent of a whole or an original amount. We're going to call this the reference value. Is, in the language of math, is an equal sign. And that is going to end up equaling the compared value. Now, a couple of interesting things here. When I take this equation, I am going to pare it down for you just a little bit and make it a little bit more palatable. Okay, I always call this percent times reference value is equal to compared value. And the interesting thing about this equation is that The compared value and the percent represent the same thing. The compared value is a number. The percent, of course, is a percent. So the compared value is a percent of the reference value. So the outside represent the same thing. This is what you're starting with. Okay, so let's go back to the original problem. We wanted to know, we found that 15% of the total cars in the parking lot is the number of cars. So the first and the last blanks represent the same thing. 15% of the cars are the numbers with oil leaks. So these two represent the same thing. And they both represent cars that have oil leaks. Now, in an equation, I've got three things here. I've got a percent, a reference value, and a compared value. If you want to solve any kind of equation, if I give you three things, I have to give you two out of the three. Otherwise, you don't know how to solve it. There is no unique solution. So I'm either going to give you the percent and the reference value, the percent and the compared value, or the reference value and the compared value. And whatever is left over, one of these blanks is going to have a variable in it, and of course we always use that as an X. Okay, so we're going to insert the values in this table. So 15% of the total cars in the parking lot, which is 140, is, and that's what we're looking for. So that is our variable. Now this is taking us through this very, very specifically and slowly, and I'll do the same thing as we finish this example. So I have 15% of 140 is X. The 15% has to be a decimal. So we are going to write that as 15.15. And I always put a 0 in front of it. That helps me remember that. Okay. We already talked of. A percent of something means we multiply. Is means equal. So now I have 0.15 times 140 equals X. Do this multiplication in my calculator, which tells me that X is 21. And to write your answer in a complete sentence, 21 of the 140 cars have oil leaks. Okay, now there's nothing magical about using X, that's just what we've always done. Okay, so our next few examples, we are going to do one where we've got three spaces here. So we're going to do one where this is the variable, this is the variable, and this is the variable, and see how that works out for us. Okay, so a survey revealed that 48% of employees take their lunch to work. If there are 200 employees, how many take their lunch to work? Okay. All right, so we have our percent. Which is going to be 48%. The percent is usually pretty easy to identify. To find out what the population is, what our reference value is, we're going to look for the word of. So of employees, and there are 200 employees, so we're looking for 48% of 200. And then the last thing it wants to know is how many take their lunch. That becomes our variable. The percent who take their lunch to work, the number who take their lunch to work. These represent the same thing, and the of number is 200. All right, so 48%, if I want to turn this into an equation, I know I need to turn this into a decimal. Decimal, which becomes 0.48 times 200 is our x. So once again, I just do my multiplication and I get that x is 96. And here's where the benchmark comes in handy. On the benchmark, 48 is a little bit less than 50, and 50 is about half. So let's see if this is reasonable. Well, 50% of 200 is 200 divided by 2, which is 100. So 48% of 200 is less than 100, so it is reasonable. Okay. Okay, let's see how much we've got left to do. I think I'll do one more and then switch videos. Okie dokie. Mark has earned 75% of the credits he needs to earn a degree in pre-health sciences. He currently has earned 48 credits towards his degree. How many credits are required to earn an associate degree? Okay, well, once again, we've got three things that we need to fill in here. We need a percent. Well, we've got a 75%, so that means we've got 75%. Then we have of the credits he needs. So that is the credits he needed. They didn't give us a number of that. He has currently earned 48 credits. So that is the number of completed credits, which is going to be 48. Well, how many credits are required? That's what we don't know, our reference value. How many credits are required? Okay, so from here I can write my equation. And I turn this into a decimal, so that is 0.75 times x is equal to 48. Now there are a couple of ways that I can think about this when I want to solve it. If I want to get the x by itself, if I have it multiplied by something, that means I divide by it. So I'm going to divide both sides by 0.75, which tells me that x is equal to 48 divided by 0.75 in your calculator, which gives you 64. To check for reasonableness, let's do 20. If it's 3/4, let's do 50% and 25%. Okay, so 50% of 64 is 64 divided by 2, which is 32. 25% of 64 is 64 divided by 4, which gives you 16. And if you add those together, you get 48, which is the number of completed credits. Okie dokie. Switching video.